So now we are going to do some CPU scheduling for first come and first serve. So let's check out the question. So if you can see, this is the process. P1, P2, P3, P4 and P5. And this is the burst time in millisecond. This is the priority. And this is the arrival time in millisecond. Given table above, draw the Gantt chart for scheduling algorithms. Calculate the waiting time for each process as well as the average waiting time. So let's start doing it. So here now we must remember that every time we start a Gantt chart, we must start with 0. So for the first come and first serve, we start with just check on the arrival time. So the process which arrive at 0 is P2, and there's no other process which arrive at 0, so just put P2 here. Which has the burst time of 7. Then we must check the next arrival time, which is 3. The process is P4, so the burst time is 2. So 7 plus 2 is equal to 9. And then the next process is arrived at 5, so it's process P1. And then the burst time is 7, so 9 plus 7 is equal to 16. And then we encounter this problem. So there's 2 processes arrive at the same time, so we must choose the least burst time between the process. So P3 is half the least burst time, so we put process P3 here, and then P5. So the total burst time is 27. So now we have done with the Gantt chart, and now we are going to calculate the waiting time. For P1, which is 9, we start at 9, and then the arrival time is 5. So 9 minus 5 is equal to 4. And then P2 start at 0, and the arrival time is also 0. So 0 minus 0 is 0. And then process P3 starts interrupt at 16. And then the arrival time is 8. So 16 minus 8 is equal to 8. Then P4 starts at 7, and the arrival time is 3. So 7 minus 3 is equal to 4. P5 starts at 17, minus the arrival time, which is 8. And equal to equal to 9. So now we'll move on to calculate the average waiting time. So we must add total up all the waiting time of the process P1 until P5. So the total for this is 25. 25 divided by 5 is equal to 5 milliseconds. So that is the average waiting time. So that's all for CPU scheduling for first come and first serve. Thank you.